Okay, for this video, we'll be going through DC circuit, tutorial 1. Okay, so let's go to the first question, asking us to calculate the effective resistance. Okay, so for 1A, we actually see that the resistors, they are connected in series. So for series, it's very simple, you just add them up. Okay, just take note that this is 4,000 ohms. So you should get a value of 4,700 ohms. Okay, for B, we see that there's series, 3 ohm, and then after that followed by 5 ohm and 4 ohm in parallel. So we actually need to resolve this parallel first. Okay, so if I were to use the formula, 1 over IFF equals to 1 over 5 plus 1 over 4, right? Because I'm resolving this parallel circuit first. So I should be able to get, okay, if I look at the answer, the IFF for this should be 2.22. Okay, meaning to say if I were to redraw, just now I didn't touch any 3 ohm, so this parallel part actually becomes 2.22 ohm. So now it becomes a very simple circuit with 2 resistors in series, therefore I can add them up to become 5.2. Okay, for part C, we see that on the top branch there's 2 ohm and 1 ohm, so we can actually resolve this to become 3 ohm, and the bottom one is 5 ohm. So again, we can redraw this circuit into 3 ohm, and the bottom to be 5 ohm, and then we apply our parallel resistors formula. You should be able to get 1.9 ohm. This is in 2SF. For D, imagine the current is going from X to Y, so there are actually 3 paths, first path, second and third path. That means all 3 of them are in parallel. No problem, because our parallel resistors can handle many parallel branches. Okay, so because there are 3 resistors in parallel, so I have R1, R2, R3, and this can be 8 ohm, 4 and 2 respectively. In the end, I'll get 1.1 ohm. Now, the only thing to take note is that if you are using this formula, the final answer that you get here is 1 over REFF, okay, equals to 7 over 8, right? So we are not looking for 1 over REFF, we are looking for REFF, so we need to switch both sides. So in the end, it will be 8 IFF equals to 8 over 7. Okay. Okay, question 2, there's no values given. Okay, so it actually depends on how you interpret the circuit, right? So we can actually role play the current. So the current that comes out from the battery is equal to the current that comes back. Remember, the current do not get used up. So L1 will actually get the most current, followed by L and also L4. So the brightness of the lamp is L1 equals to L4. But why is it that L2 and L3, they are not as bright? Because when it comes over here, and since they are identical lamps, so the current will split equally. So if the current split equally, the current will not be as much as what you get in L1. Therefore, the brightness will be lesser than L1 and L4. But because they are identical lamps, so the current will split equally. That's why we have L2 equals to L3. So if you understand this, then we can apply to the others. We know that L1 and L5 will be the brightest. But when it comes to here, we have 2 branches. One branch goes down this way, the other branch goes this way, L2 and L4. So definitely the branch with L3 will have more current because there's lesser resistance. So L3 is in the middle. Then L2 is equals to L4 because they have the same amount of current flowing through them. But L2, the current flowing through L2 is equals to L4, but it's lesser than L3 because of the higher resistance in this branch. Okay. Okay, then for C, I'll just show you the answer. You can think about it. Okay, again, L1 and L6 are the highest. Okay, for D, it is a little bit complicated because you may think that how you must think of how the current actually split up. Okay, so the current actually comes out from the positive terminal. Okay. Then it split up into L1 and L2, and then it combined back over here. And when it comes back to here, over here, it will actually split into L3 and L4 again. So they are all of equal brightness. Okay, so if I can redraw, it is actually 4 light bulbs in parallel. Okay, if you think about it. it is equivalent to 4 light bulbs in parallel. So for E is also the same thing, okay? Now, take note what's a short circuit. Short circuit is whereby there is a path of actually no resistance. So this is represented by a wire. So a copper wire in comparison to a light bulb will have no resistance. Okay, therefore all the current, right, 2 ampere, it will flow through the path of no resistance, and then I equals to 2 ampere back here. Okay, so this light bulb will not light up. Okay. Okay, so now we're going to solving electric circuit. Okay, so before we look at the question, we take note that this is 12 volts, then we have 6 ohm, 3 ohm in parallel. Then this we also have another branch whereby we have 2 ohm and 4 ohm in series. So these two are in series. Okay, they want us to calculate the reading of the ammeter when S is open. When S is open, which means current will not even flow through this branch, right? So it only flow through the bottom branch. So if I were to redraw, it will look like 6 ohm. How do I get 6 ohm? Because I actually combine them in series already. So with that, I should get 2 ampere because ammeter is over here. Right, simple. So S is now closed. Please read carefully. So calculate the combined resistance of the 3 ohm and 6 ohm that are in parallel. So they are actually telling you a lot of clues. So you will actually get it to be 2 ohm. Then calculate the current through the battery. Now we still have S is closed. So actually I can redraw the whole circuit. Okay, remember this is 2 ohm. This is due to the 3 ohm and 6 ohm in parallel. And the bottom I actually have a 6 ohm. Okay, so this is the equivalent circuit when S is closed. And after that, we can actually combine them because they are in parallel. So 2 and 6, it will become 1.5 ohm. But I didn't change this, so it will be 12 volts. So now this is the simplest circuit with only one equivalent resistance. Therefore, we are able to calculate the current that comes out. It will be 8 ampere. Now they're asking what is the current through the 4 ohm resistor. Okay, so we need to think about this current. Okay, because it passes through. This 6 ohm is actually made out of 2 ohm and 4 ohm. Okay, so this 6 ohm is because I add the 2 ohm and 4 ohm in series, and the current flowing through 2 ohm and 4 ohm will be the same, and this is the current that I want to find. Okay, now you see that this is 12 volts, right? So the potential here is 12 volts, the potential here is 0 volts, potential here is 12 and 12, and this is 0 and this is 0 volt, because in parallel the potential difference across each branch is the same. Therefore, I'm going to have 12 volts potential difference. I'm going to have 12 volts potential difference across here. And this will allow us to actually find the current that flows through, which is 2 ampere, using V equals IR. And because this current is 2 ampere, this current is 2 ampere, right? This current is 2 ampere. I'm talking about the bottom branch here. So the potential difference here will be 4 volts. The potential difference here will be 8 volts. And because they are connected in series, so the potential difference is the sum. So it's actually 12 volts, and it tallies with the potential difference across the 6 ohm or the 2 ohm and 4 ohm in series resistor. Okay, so this is how we apply. Now E, when I was marking, quite a few of you made this mistake because maybe the question wasn't clear or you didn't understand it. Describe and explain any change to the current through the 4 ohm resistor, which was this, when a 6 ohm resistor is now connected across the point P and Q. When it says across P and Q, it doesn't mean that 6 ohm come in between. It just means that across. So I need to draw P and Q with a 6 ohm resistor across it. So this will not actually affect the current flowing through in PQ because they are all connected in parallel. So this is the answer. The current will remain the same because the potential difference across the 4 ohm and 2 ohm remain the same. Okay, now we go to question 4. Now they're asking us what's the potential at A. They are not asking for potential difference. They're asking us for potential. So over here, it is 4.5 volts in potential. Over here is a 0 volt potential. So the potential difference is actually 4.5 volts, which means at A, the potential is 4.5 volts. At B, the potential is 0 volts. Okay. So bear in mind, voltage or potential difference is actually the difference in potential. So you get these two answers. So therefore, what's the potential difference between A and B is 4.5 volts. All right, so far okay. Okay, then what's the total current drawn from the battery? So I need to know the current drawn from the battery. So I need to actually calculate the current. So there are two ways to do. The first way is I can actually combine the first path into one single resistor. Okay, because 2 and 7, they are in parallel. So this is 9 ohm. Okay. And I can also combine these two because they are in series. Sorry, just now did I say that they are in parallel? 2 and 7, they are actually in series. So they become my 9 ohm. And over here, 4 ohm and 5 ohm, they are also in series. So I have this equivalent circuit. Okay, and I know that the potential is 4.5. The potential here is 0 volts. Okay, so if I want the total current drawn from a battery, I can go on to find the equivalent resistance. So if I work them out, this becomes 4.5 ohm. Okay, 9 ohm and 9 ohm. You take if these two resistors are in parallel and they are of the equal value, you can actually take the value of 1 and divide by 2. Okay, so this is a useful trick. So with that, I can calculate the current to be 1 ampere. Okay, or I can apply my sum because this is 4.5 volts. This is 4.5 volts. So if I use V equals IR, the current through here will be 0.5 ampere. The current through here will be 0.5 ampere. And therefore, the current that comes into this knot before it's split up is 0.5 plus 0.5 equals to 1 ampere, right? This is sum. Now they're asking us for the potential difference between X and Y. Oh well, so we can just actually use this circuit that we have drawn just now. We have, actually let me redraw this to the original because I need to show my X and Y. So I have a 2 ohm here. I have 4 ohm. My Y is here. And this is 7 ohm. And this is 5 ohm. My X is here. My Y is here. Okay. And if you understood this, 0.5 ampere, I can apply it to here. So this is 0.5 ampere. The current through is 0.5 ampere. They split up equally. Okay. So I need to know the potential of Y and I need to know the potential of X so that I can know the potential difference between XY, VXY. Okay. So over here it is 4.5 volts, right? And because this is 2 ohm, the current flowing through is 0.5 ampere. So the potential difference here will be 1 volt, right? Meaning to say Y is actually 3.5 volts. Okay. We can test this out because the current flowing through the 7 ohm is 0.5 ampere. V equals to IR. My I is 0.5. My R is 7 ohm. So this makes my potential difference to be 3.5. Right? And over here, remember the potential is 0 volts. So it is true. 3.5 minus 0, you get a potential difference of 3.5 volts. So Vy, the potential at Y, is actually 3.5 volts. Let's do the same for X, and you find that a current of 0.5 ampere flows through the 4 ohm. So there's a potential difference of 2 volts here. Meaning to say 4.5 minus 2, my X will be 4.5 minus 2 equals to 2.5 volts. Okay, so what's the potential difference between X and Y? So we take the bigger value, subtract the smaller value, so Vxy equals to 3.5 minus 2.5 equals to 1.0 volt. Okay, so take note of this question. This is not commonly asked, right? Okay, question 5. 3 cells each of EMF of 2 volts. That means their total voltage is 6 volts. Of negligible resistance are connected to 150 ohm resistor and 300 ohm in series. So I can quickly draw. And because they are in series, why not I just straight away add them up, become 450 ohm. And they are asking for the current flowing through each resistor, same current in series, therefore it will be 0.013 ampere. Okay, so this applies to both answers. Now, what's the potential difference across the ends of each resistance? So let's break it up. Just now I drew this. I have 150 ohm, I have 300. They want the potential difference. So the potential here is 6 volts. The potential here is 0 volts. Okay, so what's the potential difference here? I apply the formula V equals to IR, and because the current is 0.013 ampere, right? So I'm going to get a value of 2 volts. So here I'm going to get a value of 4 volts. Okay, so 2 and 4 in series, you add them up is equal to the total EMF. But you also have learned your potential divider formula, right? So I have 6 volts, I redraw 150 ohm and 300 ohm. Now, potential divider formula only works for series, right? Not for parallel. So we can try it here. So V, I call this V150 ohm and I call this V300 ohms, okay? Which is the potential difference across 150 ohm and 300 ohm respectively. So if I apply the potential divider formula, V150 ohm is equal to 150 ohm over the total resistance plus 300 multiplied by 6. Okay, so this is like a ratio. Remember, 小明小强. So I should get 2 volts. Then similarly, I do 300 ohm equals to 300 over the total, right? Your PSLE math. So I should get 4 volts. In the end, they must add up to become 6 volts because sum, same, sum. Okay, draw a complete diagram that shows the connection of the cells. Okay. Because they want us to draw in an ammeter and 2 voltmeter to measure the current and voltage across the resistor. So remember, series, ammeter always connected in series, voltmeter always in parallel. Now question, if here is the positive, here is the negative, right? Ammeter here should be negative, here should be positive. How about voltmeter? It should be negative, positive, negative, positive, because positive connected to positive, right? Negative connected to negative. Okay, so this is how voltmeter and ammeter should be connected. If not, in your practical, you'll see that the needle actually goes to the left-hand side after the 0, okay? And you cannot get any reading. Okay, last question in tutorial 1. A number of 8 ohm resistors are available. Draw diagrams to show how you obtain to give an effective resistance of 24. So actually this one's simple, just 3 times 8, 24. 18, you need to do a bit of thinking. So 8 plus 8 is 16. Then if I put all 4 of them, another 4 of them together, so I'll get 2 ohms. So total I'll get 18 ohms. Okay, so this is for tutorial 1. I'll be doing tutorial 2 soon.